Hello, and welcome to Engineering Thoughts, where engineering minds come together to talk about topics of mutual interest in our industry. I am Neil Webb, and I'm joined today with Reentseng Molapo and Lerato Kanetsi. Reentseng is the Divisional Manager of Operations at Lesotho Highlands, and Lerato is the Senior Engineer in charge of the Muela Hydropower Station in the same project. Now today, we're going to be talking primarily about maintenance in a major operational facility. We've come a long way in the last 13 odd years that I've been involved in the project, and we have seen that the requirement for maintenance of the system has changed or developed or matured, perhaps is the word to use, over the years. The first real inspection that took place in around about 2012, which I believe is when you first started, although Reentseng, of course, knew it well by then, having helped with the construction. That was the first time that we had had the opportunity to do an in-depth inspection and maintenance operation of the tunnels. Because the first inspection in 2005, I understand, was just a quick look-see. We, as a result, have when I say we, I mean the project, has a good understanding of the requirements of maintenance in a project of this nature. So, Reentseng, what did you foresee would be the maintenance requirements when you first started and got involved with the project?
Thank you, Neil. There was already some engineering thoughts at the very beginning when the project was constructed, in the sense that the actual operations and maintenance manual specified when we'll do the maintenance activities or inspection activities. And at the same time, the original equipment manufacturers are also then specifying that, if you buy this equipment of mine, you will have to do this at this time or in this frequency. So it's already specified, but in the tunnels or the major infrastructure of the Lesotho Highlands Water Project, it was specified as maybe you will have to do this. For example, they said you should do the inspections of the tunnel in between 5 to 10 years. So when we started, we sort of said, okay, be conservative, do it the minimum time, 5 years. And then you learn whether the 5 years is adequate or it is too little or too much. But we saw that, let's still play within the 5 to 10 years. So it's like that. That's how we have proceeded going forward.
And one of your responsibilities, obviously, is the planning of these maintenance activities. How do you balance the operational and maintenance requirements of the scheme, given that operations wants water and power? Maintenance means you have to stop.
Yeah. Well, fortunately, when we started, or even when the people started, I'm not so sure, but when we did the operations and maintenance, we recognized that really the requirement of water and the requirement of electricity sort of coincided. You require more electricity in the winter and you require more water in the winter period because there is no rain. So it was really such a coincidence that they are required almost equally at the same time.
That's interesting.
So then it sort of made our planning much easier, in the sense that we realized, okay, you need water in the winter period because there's no rain. You also need electricity in the winter period because you need more to heat your houses and so on. So then we said, okay, we'll do maintenance during the summer period. And in the beginning, we started to do it immediately after the winter period, which was maybe starting in October. But then we realized October, November is close to Christmas when the contractors are on holiday.
Yes.
So then we had to move it to the beginning of the year, as in, start it in January, such that then you sort of have more flexibility to actually do it there. So that's how it was developed, the planning.
Okay.
All right. Other than that, what is required is to then involve the stakeholders, the customers, especially the people that need water. RSA. So we talk with the Department of Water Affairs on this side through the TCTA, and in Lesotho we talk with the Lesotho Electricity Company for the electricity requirements in Lesotho, and then the governments to know that there will be an outage. This is how it's going to be. how long it's going to be, it will impact on the royalties, because then when we deliver water through to South Africa, Lesotho gets the royalties. So you have to do that part as well.
So there are many aspects that get affected by the interruption of the system. You no longer have power, you no longer have water, you no longer have income. Yes,
Correct.
Yeah. Lerato, you started with Lesotho Highlands as a young new engineer. How does it feel to now be in charge of a full-on hydropower station?
It's surreal. It's a very big responsibility. I feel the responsibility to keep the station alive, just like the people before. The station was well maintained to a point where we came in and had an opportunity to work on the station. So I feel a sense of responsibility to actually keep that legacy going, to maintain the station such that future generations can also have an opportunity that I got presented with.
Sure. Reentseng, we were talking about the multifaceted aspect of an outage. With the design of the system such that you actually have this intermediate dam at Muela, is it possible to, for example, undertake maintenance in the delivery tunnel whilst still maintaining throughput into the Muela Dam? Or does it all have to go all the way through to the Ash River outlet?
It has to go all the way through, because in the treaty that governs the Lesotho Highlands Water Project, all the water that you release from Kanetsi has to go all the way to Vaal.
Okay.
And at the same time, the Muela Hydropower Plant, or the Muela Dam that you referred to, even though it's there, it's really a small reservoir. It cannot really take a lot of water that we would use to generate electricity, such that then you can then continue generating electricity and then maybe not delivering the water through to South Africa.
So you can't divert the water and let it flow on down the outlet from Muela?
No, you can't. You are not allowed to do that.
Okay.
At the same time, if you were to do that, then Lesotho would lose the revenue that you get from the water, and South Africa will not get the water. Yes, some parts of South Africa will get the water
through the river,
the river system, but really it is primarily aimed to be coming to the Vaal Dam to be used in the Gauteng province.
Okay. But if there was an emergency of some description, would that affected the delivery tunnel only, irrespective of what the treaties say? Would it be physically possible to continue operating?
It would be physically possible to operate the hydropower plant, but then it would say the two governments have to agree that we can continue operating the hydropower plant, and then let the water be diverted downstream the Muela Dam, and not to come through to South Africa.
Right.
Yes.
Now, while we're on the subject of downstream, Lerato, measuring power is easy. Okay, you get megawatts out of the dam.
Yes.
How on earth do you measure the amount of water that comes out of the Ash River outfall?
We don't measure it at the Ash River outfall. We measure it while it's still in the tunnel. Yes, so we have installed flow measuring equipment in the tunnel. It's actually in a flow measuring equipment chamber. So the tunnel comes out and it's a pipe in that chamber. We've installed 2 flow measuring systems. One is backup for the other, just to confirm that the readings are correct. We have an ultrasonic system and a magnetic system. So every day we take readings just to measure how much water goes through. And then at the end of each month, TCTA comes through and we do calibrations of the equipment together. So that's basically how we measure.
Okay. So you don't have some good old-fashioned thing like a notched weir at Ash River as a backup, or do you?
No, we just use the flow measuring
Just the flow
equipment.
meters.
Yes.
Okay. So that must be a huge responsibility, is ensuring that those meters remain functional.
Yes, that's why we make sure that every month we do the calibration and they're reading properly.
Right. And Lerato, what areas of materials protection and maintenance do you think are underestimated in a project or an operation of this nature? Now, I'm not saying that you, Lesotho, have underestimated them, but if we were to talk about water transfer schemes, dams, tunnels, pipelines, flow meters, gates, all of that, what aspects of that sphere of industry do you think are often underestimated in terms of maintenance requirements?
I think it's the corrosion protection. Usually we focus on maintenance of the moving parts, how the system works, the protection of the equipment, the electromechanical aspect of it. But we often underestimate the damage that can be brought about by the effect of corrosion. And usually when we think of coating equipment, we think about the aesthetics, and we don't fully give it the attention it needs in terms of the surface preparation and making sure that it is correctly protected. I think that's the industry that is most underestimated in the engineering field.
Interesting. Reentseng, going back to our downstream situation again, since the onset of the scheme, which is now, well, it's been in operational for what now, nearly 30 years, isn't it? It started in 98. There have been a number of mini hydropower plants that have been built on the Ash River between the Clarence and Bethlehem. How does the operation of those power plants affect your decision-making process? Or is it the other way around?
It is the other way around, in the sense that really the project, as it is now governed, it is governed at the highest level, at two governments. It's not governed at our level. So we have a prescribed, written down how to run this and operate this infrastructure.
Right.
But yeah, when we do the planning, we also involve them. We need to then communicate. They are our stakeholder, key stakeholder, in the sense that they need to know what is going to happen, when is it going to happen, how is it going to happen, such that they can do their planning around how that information. So that's how we have been working together with them, and I believe at this point in time we've been really working well with them. Yes.
So how do you feel, and this question really I think is addressed to both of you, how do you see hydropower as a future industry in the Southern African context, as an opportunity for young engineers coming into the field? Is it something that has a future? I mean, obviously we have to keep our systems operational, and therefore we have to have a natural progression of skilled personnel. But do you think we're going to see an increase in the use of hydropower?
I definitely see an increase in that, in the sense that really we are moving to or we have already moved into that era where the world is sensitive to the use of energy or renewable energy. So hydropower really plays that role. It's not contaminating the environment, even though that infrastructure takes a lot of land.
Yes.
It does affect, the environment, but it only has that impact of, taking away available land that could be used for something else. But in terms of producing the required energy that the human beings require now as an essential necessity, it is really playing a big role. And I see it as an opportunity for all engineers to learn, how do we do this? There is opportunity for civil engineering, electromechanical, as Lerato is saying. So, yeah, it's there. It's available for young engineers to try to explore this as a profession.
Lerato, you mentioned the importance of corrosion protection in a water conveyance scheme. You've both been involved in the recent shutdown, as you mentioned earlier. Can you walk us through some of the most important aspects of that whole project? I mean, when did we decide that we actually no longer would be able to carry on as normal, that we now needed a major refit, so to speak?
Like you said, we have been inspecting the tunnels. I think the first major one was in 2012. And at that stage, there were already signs showing that the corrosion protection used in there is starting to fail, but it was not as significant as when we discovered it in 2019. So it was progressive inspections that led us to this, because we realized that the material used had come to the end of its life span. So it needed to be refurbished, for lack of a better word. So that is the journey that took us here. And then we did a study to see the type of material that was used, and we wanted to improve on it and use a material that would perhaps last longer, because the type of failure that we had was blistering, and that was caused mainly by the humidity levels in the tunnel and the fact that we had used an epoxy that requires multiple layers. So we had interlayer blistering. So we decided that maybe we can choose a material that is better applied as a single coat to avoid that interlayer blisterings, and try to control the humidity while we apply it and the environmental. So it has been a journey from inspection to learning what could be improved, and that's why we got to this point.
I imagine that the application conditions of now working in the tunnel where the whole mountain is saturated as a result of the impoundment of the Kanetsi system, compared to when the tunnel was bored originally through dry rock. They must be very, very different.
Very. The temperatures in the tunnels are just not user-friendly, to say the least.
To either people or paint.
Yes, we struggled to get delta T that is above 3. Most of it was below 1. We struggled to get humidities that were below 80%. We struggled with just the airflow, because the tunnel inlets are so far apart. So we had to really, really sit down and plan how we were going to control the environmentals during the working period. And it is quite a challenge, because now the tunnels are so long. To actually get the equipment on site to the actual work area was also a challenge. So it is also in the tunnels, you cannot use fumes, and power supply is a challenge. It has been such a challenging work environment. And the fact that the tunnel is not dry, there is so much seepage water coming through that had to be diverted from the work area. It has been an adventure, to say the least.
So in spite of the fact that the Kanetsi Dam was shut off, so to speak, by the primary gate, you still had a lot of water flowing through the non-steel line sections.
Correct. In addition to what she said, I think the good thing about doing this maintenance, you could learn on it and then maybe improve on future systems. And as you were saying, during the engineering or construction, it wasn't anticipated that would be, a lot of groundwater around to deal with. So there was no system made to work with that. So we had to improvise on the spot to try to work around these environmental conditions that you really were not really prepared for. But I believe in the next outage, people will be informed. Expect this. Maybe we would then already devise means and ways of how to deal with it, knowing that it is so severe and it can affect the outage program so severe that you are delayed by several weeks on the actual program of implementation.
We had an unusual summer season in that in January or December, January period, we had exceptional rainfall in South Africa, which I think possibly took the pressure off a little bit in terms of the end date of the outage. But did that rainfall make the conditions in the tunnel more challenging at the same time, or not really?
Absolutely. The tunnel has open spaces to the environment. We have a access shaft, and that is not covered. We have rain coming through there that contaminated our work area. And Because we were working in different sites simultaneously, when you are trying to control the environmentals from one side that is upstream of the other side, it affected the works downstream because now the airflow, you're cutting off the airflow, and you might be blasting upstream and you're trying to extract the dust. And the other side, they need air for ventilation. They needed the tunnel to be open. So it was bringing challenges such that sometimes when you're trying to draw in air for ventilation, you're bringing in the moisture from outside when it's raining, and you're contaminating the next work area. So as much as we were in the tunnels, it did affect the environmental conditions.
So it would seem that certainly one of the lessons learned that you, as you mentioned, is that future operations need to have some sort of overarching monitoring and control in place to coordinate work between different sites.
And because of the time interval, what it might mean is that we have to develop those methodologies today.
Yes.
Because then in 30 years down the line, someone would have forgotten maybe not even have a knowledge of these challenges that we're talking about.
All those new engineers that come out without dirty shoes are going to have all sorts of fancy ideas.
Yeah.
And you and I won't be around to teach. Lerato might still be around to teach them. Hey.
But I want to go back to the fact that it rained. I really think it was really a blessing in the sense that it allowed us to complete the work without too much pressure. Because had it not rained, or maybe had South Africa faced a situation of drought, we would not have been allowed to continue, maybe even for a week more. So the fact that it rained, it really allowed us to finish the entire project as we had planned, even though we ran late.
Over time.
Yes.
It took some brave decisions to make that happen.
What really helped again was that we had our principals go into site to go and appreciate these challenges that we're talking about. They were actually went into the tunnels and saw that there is this really a lot of seepage that the people have to deal with it. And they actually had an appreciation of the difficulties of how to control this. The working environment, as Lerato said, wasn't an easy environment to work within.
Right.
Yeah.
Right. So you weren't faced with the situation of two governments sitting in their ivory towers dictating.
Yeah. They really went into the tunnels.
That's good to hear.
Yeah.
In terms of operation of a scheme like this, do you see a future for the application of AI?
Obviously, yeah. It is really expected. That's how life goes. AI is improving our lives. In the Lesotho Highlands, we use a lot of instrumentation to gather information and get data and make observations of how the systems are going in terms of their time. So with AI, it will really help us analyze this information that we have been gathering to actually then inform. And the good thing about it, I believe, it's going to give you quick information to say, well, your infrastructure is trending like this, so you need to then make a decision how you react to certain possibilities of how the system is behaving.
You have 30 years of data.
Over 30 years, because it started well before construction. So there was information gathered before construction to see how the sites were behaving, and then during construction and then post-construction. So there is that information that it has to be all integrated into one information.
And not only that data, but you have the climate data, you have the water usage data, you have the electrical data.
Yeah.
Can you imagine trying to integrate and analyze all that data manually? I guess
that's where artificial intelligence is going to be.
That's where it's going to be
more useful.
More useful, yes.
And it's certainly going to help us to predict, because currently we are highly dependent on preventative maintenance. We try to prevent things before they occur.
Yes.
But AI is going to assist us to move now to predictive maintenance.
Right.
So I think it's definitely going to help us.
Super. Thank you. Well, Lerato, Reentseng, thank you very much for joining me in this discussion. It's really been fascinating.
Thank you.
And to you out there, I hope you have enjoyed this discussion of engineering thoughts. Please remember to subscribe, turn on your notifications so that you will be in line to receive future topics of mutual interest. Thank you.